Previously, we solved equations with an odd root and a variable outside the root. When we solve equations with an even root and a variable outside the root, sometimes something strange happens. So here's an example of solving an equation with an even root. We have the square root of x plus 5 equals x minus 1. Rewriting in terms of a power function, we'll have x plus 5 is x minus 1 squared. We work out the right-hand side. X plus 5 is x squared minus 2 times 1 times x is 2x, plus 1 squared is 1. And now we have a polynomial equation. We'll subtract x and subtract 5. We get 0 equals x squared. Negative 2x minus another x is negative 3x. 1 minus 5 is negative 4. X squared minus 3x minus 4 equals 0. Now this is a quadratic equation. We could solve it using the quadratic formula, but in this case I think it's easy to factor. Leading coefficient is 1, so we can use the shortcut. We want two numbers that multiply to negative 4, so we'll have one positive and one negative. And we want them to add up to negative 3, so I think that's going to be positive 1 and negative 4. Now if this product is 0, one of the factors is 0. So either x is negative 1 or x is 4. So that gives us two solutions to our polynomial equation. But look what happens when we plug those back into the original radical equation. When I plug in x equals 4, I'll have the square root of 4 plus 5. That's the square root of 9, and that's 3. Meanwhile, 4 minus 1 also equals 3. No problem there. But if I plug in negative 1 on the left, I'll have the square root of negative 1 plus 5. That's the square root of 4, which is 2. But then I have negative 1 minus 1 is negative 2. Those are different. What happened? When x is negative 1, the right-hand side of this equation was negative. When we squared both sides, when we rewrote in terms of the power function, that erased the negative sign on the right-hand side. So we got a solution to the polynomial equation that was not actually a solution to the original radical equation. When we have a solution that shows up in the solving process that wasn't actually a solution to the original equation, that's an extraneous solution. If we take an even power on both sides of an equation, this can introduce an extraneous solution if one side of the equation is negative. So our radical functions were one-to-one, but their inverses, the even power functions, they are not one-to-one. If we eliminate a function by applying an inverse that is not one-to-one, we risk introducing extraneous solutions. Just like we could for rational equations, we can handle the possibility of extraneous solutions in two ways. One, we can flag values that would result in an extraneous solution. In this example, the only valid solutions made the right-hand side positive. That is, x minus 1 had to be positive. So solving that, we would get x is greater than or equal to 1. So we would know that the solution -1 would be thrown out because it's not greater than or equal to 1. Or we could check solutions in the original equation. For rational equations, because the possible extraneous solutions were just a small number of values, it was easier to flag them. For radical equations, it's usually easier to just check. As the equations get more complicated, flagging the potential extraneous solutions becomes harder. And so it's easiest to just go back, plug into the original equation, and see if it works.